Hello guys, welcome back. And in the following videos, I'm going to cover how to implement JWT, which will integrate JWT with Spring Security. Okay. In traditional application or system, what is going to happen is when user logs in, okay, and it will go to our server side. Like server side will check the credentials to see if it's correct, and then the server side is gonna do what? The server side is gonna create a cookie, and the cookie gonna be passed along with the response to the browser, okay, to our client. And also in the server side, gonna have a session being stored. This one gonna be stored in the server side, and this cookie we're going to be stored in the client. It's going to use some header in response called a set a cookie. And when the browser gets a set a cookie, it will save the cookie in the browser memory, okay. And then in the following request, when user want to make a request, this cookie gonna be sent along with the data to the server side. Because by default, if you have any cookie on the current website, the URL, any request when you make the cookie, the browser will automatically send it with the data to the. And once the server side get your cookie, and he will compare what's being stored in the server side to see if you are the same user. So this is a traditional application. And it's gonna have a problem. One is session. Record need to be stored on the server side. That's how the server side know who you are the one. Who are you logged in before? Do you have the permission before? Do you have permission to do the thing? That's the session. We have to maintain the state. And with this way, it's not easier for scale, because suppose I have 4 servers. Okay, or let's do 3. Okay, and here have a load balancer, and this is a user. Okay. And with user, when he make a request to go to /login, and login, the load balancer hit this server, okay, and this server will have a session. This server will have a session, and he respond back and with a cookie, okay. And next time when the same user do something like I want to make a request to /users, okay. /users/products. Here we'll also have a cookie with it. But now this time this request goes to this server. And as we know, when it logs in, the session only stored in this server because login is handled by this server. But next time the get /users, it goes to this server. So if this server don't have this session, it will consider the user is not a logged in user, right? So in this case, for this kind of application, we have to repeat the session in all servers. Okay. Otherwise, you're gonna facing the problem I just described. So with session in memory, load increased drastically in distributed systems. You have to repeat it. You have to duplicate a session in all the servers. And you may have CORS with this kind of attack, which is cross origin request policy. This is actually not a big issue, because by default, the browser not allow you to make AJAX request to different domain, which is either your IP address is different or either your port number is different. And the CORS also happened for what? CORS also happened in like a JWT token-based system too, okay? So this one, CSRF, cross-site request forgery. This attack must be writing on the session. This is kind of like when in previous video, last video, we fix a problem when we use make a post, right? We have to disable CSRF, because CSRF is when, suppose here I have a client and this is my server, okay, and when we want to make a post, which is a transfer money, okay, we need to have a form. So I say I want to transfer money. So the server side, this one I want to transfer money. The server side will give you what? Will give you a form to fill from which account, from which one to which account, okay. And here is amount, okay, amount, and you have a button. With this form, the server side will give you one called the CSRF ID. and which is a random number, random string, okay, random string. And this CSR this ID is going to be used once. And if for any user want to copy your form but don't have this CSRF ID, and which is only generated by the server side, okay, the server side will say, oh, this is not valid, you are not allowed to access. That's what happened in our previous video. You must have this CSRF ID, and this ID is generated by on the server side, and this ID will only be used once, okay. This is a tag. When we use in session-based, you have to be aware of this attack, and the typical way to solve is have one-time use random number, okay. And with the token-based authentication system, yes, user logs in, and the server side will check the credentials, and the server side will generate what? A token, okay. And this token, it will send to the client side. The client side will decide to where to store. Either store in the local storage or session storage, or either store in a cookie. And for the server side, it doesn't remember any context about the client. The server side doesn't remember anything, and it just based on the token given to you. And but for the next request from the same user, you must provide a token, okay, to the server side. Server side gonna do what? Server side are gonna verify your token. Are you logged in? Do you have the is the token expired? Is the token malformatted? This kind of things, okay. So it's a stateless, self-contained. Stateless talking about it what? The server side don't store users' context, okay. And it's a scalability. No need to store session. Suppose here we will give some example as we did. Here is a load balancer, and we have 1, 2, 3 server. When user make a request, /login, okay. And this load balancer redirect the request to handle by server A. And server A, after check username password is correct, he will give what? He will give a token. And server A doesn't store anything, any information of the customer. And this token will be saved in storage, like a session storage, local storage, or cookie. And now, next time when the user make a request, suppose we go to sam/users, okay. And when it make a request to /users, the user also need to give a token along with the request. Suppose now this request go to the server C. Server C going to do what? Because here we have token, right? So server C will based on token to check if you have permission and those kind of things, okay. Do you have a role to do it? Is the token expired or things? If it all pass, it will return the result to you. So A is generate token, C will verify token. A, B, C, these servers don't need to duplicate the session as we mentioned earlier. So no need to store the session in memory, okay. There's no CSRF tag because CSRF tag is based on session. And in the token-based system, there's no session needed, okay. And those three is talking about kind of like JWT, okay, like digital signed, mobile ready, decoupled, because your client, the server side, can be any technique. The server side can be what? Can be made using Node.js application, you know, can be made with Java-based, and the client side can be what? It can be React. It can be what? It can be Angular, right? No, it can be Vue, okay. So it's a completely decoupled. No need to be the same technique, okay. Now let's take a look at JSON Web Token. JSON Web Token is open standard that defines a compact and self-contained for securely transmitting information between parties as a JSON object, okay. And JWT can be signed with a secret or public or private key pair using different algorithms, okay. And you can choose it. It also has built-in ones. Or it also has the dependencies can do that. And the information, it will be verified, trusted by digital signed, because only you know the secret. Only you know the private key, okay. It's compact, compact, it means just a simple string, a string, okay? The smaller size, JWT can be sent through a URL because just a string, plain text, okay? Post parameters included into HTTP header, it's a string, plain text, okay? So you can send it in different ways. You can pass a URL as the query parameter, you can pass as the post parameters, you can add in the HTTP headers, okay? And again, it's compact, it's a smaller size, so which means the transmission is fast, okay? Simply a string in the format is a header dot payload dot signature. 3 parts: header, payload, signature. We'll talk about it one by one. It's self-contained. The payload contains all the required information about the user, avoiding the need to query a database more than once, okay? Suppose in the payload, I may contain about the authorizations. So when I need to go to the server side, I don't need to query database to get authorizations again. I just using everything inside the JWT. We'll show a demo later. So the token will have 3 parts separated by the dot. You have a header, payload, signature. This is the header part, this is the payload part, this is the signature part. So you're gonna have 1, 2, 3. Okay, and the first part is using base 64. Second part is base 64. Only this part is digital signed, which is encrypted. You don't know unless you know the secret. Okay, otherwise you cannot find the information because JWT is not to hide the informations to you. Okay. Now let's take a look at about a header. The header typically consists of 2 parts. The type of a token, which is JWT, okay, which is this one, type of token, and the hashing algorithm to be used in when we sign the signature, okay, which is this is the algorithm choose, and this is the one we're going to use later, okay. And this is JSON is a base 64 you are encoded from the first part of JWT, which this string. You just use base 64, it can be automatically converted. It's not hidden, okay? So let me show you. We can get this string, okay? Then we use base 64 decode. You pass this string here and you decode. You are getting exactly the data, which is algorithm and type, because this part is not trying to hide, no one knows it. You can know. I just need to verify the token is valid, okay? And if you modify information, we know you modified, okay? So this is this part. And now next one, the payload part. The second part is a payload, which will contains claims. Claims are statements about entity, typically user, and with additional metadata like issuer, the expired date, all the things. There are some 3 parts reserved, which is like issuer, issue the date, those. And it may have some public, can be defined with JWT. To avoid a collision, they should be defined in this one. They may have, but I didn't never use this one, okay? Because for these 2, I don't differentiate them. There's a private. Private one is the customer control. What do you want to be shared? I want to share the ID. I want to share the authorities. Okay, that's what. But generally, we don't share password, okay? And see here, the payload, we will have a subject, okay? You will have a name, that's what the information I want to share. This is issue the date and time. This is one. Probably you also need to set it for expire time, And this payload is also base 64 encoded. And for this string, for this yellow string, you can also decode it. Okay, let me show you this part. So this part, we are not trying to hide. And we decode, you will get everything like subject, name, and issue that, because we are not trying to hide. That's the reason don't put a password here, because if you put a password, they won't know. Because the JWT, we are not trying to hide all the information. We just verify all the information you send is not expired, it's not malformatted, it's not corrupted, okay? And this is guaranteed by the last part, which is a signature. To create a signature part, you have to take the encoder header, the encoder payload, and the secret, the algorithm specified in the header, and to sign it. This part, it's been signed. You cannot decode it anymore. See, if I use decode, you won't get it because this part is to guarantee our JWT is not a corrupt JWT, okay? And the second is to verify the sender of a JWT is who it says it is to ensure that a message was not changed along the way. And we can also go to here to do a test. JWT.io. Again, you can play it. Okay, so here is JWT, here is the algorithm, the second part. This is the header part. The header will have algorithm type, okay, and here whenever suppose I change it, I will have a ID, ID, and I will have ID 1 2 3 4 like this way. Every time, see here, every time I make changes, you will see the second part is changed and also last part is changed. Because the last part of signature, it will based on the header, it will based on the payload, and based on the secret you give. Okay, so whenever I change here like a 4 1 2, okay, you will see also last part is also being changed. Okay, that is JWT. Only the last part is being signed, and when you change the secret, it's also. If you want to change this too, but only the signature part. Okay, 3 parts: payload, header dot payload dot signature. Okay, this is the JWT. And how does JWT works is eventually in the authentication, when the user successfully logs in with their credentials, a JSON Web Token will be returned and must be saved locally, which local storage, session storage, cookie, whatever technique you use. Okay, and whenever the user want to access a protected route or resource, the user agent should also send the JWT, typically with authorization header using a bear schema. Okay. It's going to be look at authorization and bear, you give a token. In previous demos, what we use is actually basic. We use authorizations, and here is a basic. Then we give a username password, okay? And we will have our practice next video, okay? Thank you. See you next time. Bye-bye.